Okay, our next learning target is given one trig ratio, find the remaining 5 trig ratios. It's very similar to the last learning target with the triangle and finding all 6. But let's pretend that you're given that the tangent of some theta is 1 over 4. You're given that. How do you find the other 6? Well, we know that this, according to our definition, 1 is opposite of theta, and 4 is adjacent of theta. And we know that if we're talking about these, we're talking about a right triangle. So you need to draw yourself a right triangle. It can look any way you want it to look because you're just telling what values you want. And you need to pick theta. Obviously, it's not the 90. So either this can be theta or this can be theta. It doesn't matter where you put it. I'm going to put theta down here. I know from theta, my opposite is 1. And my adjacent is 4. Then I can use the Pythagorean theorem. 1 squared plus 4 squared is 17, and the square root of 17 is going to be my hypotenuse. Now you go to work. Sine of theta. Opposite over adjacent. 1 over the square root of 17. Square root of 17 over 17. The cosine of theta. Adjacent over hypotenuse. 4 over the square root of 17. 4 square root of 17 over 17. Tangent we already know. Our reciprocal ones. Cosecant. Cosecant of theta. Hypotenuse over opposite. Or just flip the sign. So square root of 17 over 1, or just the square root of 17. Secant. Hypotenuse over adjacent. Square root of 17 over 4. It's the reciprocal of cosine. Cotangent. We probably could have gotten the cotangent without even drawing the triangle. Because if I look at tangent and I flip it around, it's going to be 4 over 1. That's the reciprocal. These two are reciprocals. That's your learning target. Given one trig ratio, find the other 5 by drawing a triangle. I'm going to work with algebra.